Butters, what are you doing?
I'm trying to say this imagined number thing, but I just don't get it. There's like nothing there. I don't get it.
Butters, they're not actually imaginary. They're represented by the letter I in math.
And I equals the square root of -1.
So maybe you should put something on your paper.
Well, this looks normal to me.
Imaginary numbers follow a pattern. I equals the square root of -1. I squared equals -1. I to the third equals -I. I to the fourth equals 1.
And then as the powers increase, the pattern repeats.
Using an equation such as x squared plus 1, we can see that this graph has nowhere where it touches 0. But using imaginary numbers, we can find where this equals 0. And that would be root -1, which would be the imaginary number I.
For an example, one time that you would use I is in the quadratic formula when under the root is a negative.
Pi is the approximation of how many times the radius goes around the circumference of a circle, approximately 3.14.
E is an exponential function that can be represented by 1 plus 1 over n to the n power, in which as n approaches infinity, you get approximately 2.718.
All these magical numbers can be combined into what we call Eulers' formula. It is represented by e to I times pi plus 1, which equals 0.
This formula is important because it relates the 5 fundamental constants of math: pi, e, I, 1, and 0. Euler's formula describes 2 equivalent ways to move in a circle.
Exponential growth continuously increases by a certain rate. For imaginary exponential growth, it continuously rotates a number.
Growing for pi units of time means go on pi radians around a circle.
Therefore, the equation e to the pi I means starting at 1 and rotating pi halfway around the circle to get to -1.
Exponential growth with real numbers causes the function to grow at an increasing rate.
However, the continuous imaginary growth rate causes the function to grow at a 90-degree rate, which causes it to rotate.
This rotational growth makes e to the I times pi equal -1 and is fundamental to Euler's formula.
This is a visual as e grows to the power of I, and as you can see, it grows around in the circle just like pi in radians until it reaches -1. How many mathematicians does it take to screw in a light bulb? Negative e to the power of I pi.
That's 1.
Why can't I fix the stupid light? Oh,
There it goes.
Maybe it takes 2 calculoids.
Do you know how many mathematicians it takes to screw in a light bulb?
All these magical, what was I gonna say?
How many mathematicians?
This rotation causes, this rotational growth.
How many
Butters! You got 2.
It has 1 over n. Why did I say 1 over